It is common for household switch boxes to have 240 volts present even when the switches are turned off. This is because the power supply for the switches is typically a 240 volt circuit, and the switches simply interrupt the flow of electricity to the lights or other devices they control. It is important to be aware of this potential hazard when working on electrical systems. It is always a good idea to use a voltmeter to check for the presence of voltage before touching any wires or components. You should also wear appropriate safety gear, such as insulated gloves and safety glasses, when working on electrical systems. It is also a good idea to install warning labels on the inside of switch boxes to alert others to the potential presence of 240 volts. This can help to prevent accidents and injuries. Here are some additional tips for working safely with electrical systems. Firstly, always turn off the power at the circuit breaker or fuse box before working on any electrical system. Secondly, use a voltmeter to check for the presence of voltage before touching any wires or components. Thirdly, wear appropriate safety gear, such as insulated gloves and safety glasses. If you are not comfortable working on electrical systems, it is best to hire a qualified electrician. Electrical safety is paramount when dealing with any electrical system, whether it is in a household, commercial building, or industrial facility. Understanding the potential hazards and taking the necessary precautions can prevent serious injuries or even fatalities. In the context of household switch boxes, the presence of 240 volts can be a hidden danger, especially for those unfamiliar with electrical wiring. This narration will delve into the reasons why 240 volts may be present in switch boxes, the safety measures to take, and general best practices for electrical work. The presence of 240 volts in a household switch box typically arises from the way electrical power is distributed in many residential settings. In North America, for instance, a standard residential electrical service is often a single-phase, three-wire system. This system provides 240 volts between the two hot wires, often referred to as L1 and L2, and 120 volts between each hot wire and the neutral wire. The 240 volts are used for high-power appliances such as electric stoves, clothes dryers, and water heaters, while the 120 volts are used for lighting, small appliances, and most general-use outlets. Switch boxes may contain both 120 volts and 240 volt circuits, depending on the wiring configuration and the appliances or fixtures they control. Even if a switch is intended to control a 120 volt lighting circuit, the presence of a 240 volt circuit in the same box can create a hazard. For example, a multi-gang switch box might house switches for both lighting and a small appliance, with the latter potentially connected to a 240 volt circuit. When working in such a box, it is easy to inadvertently come into contact with the 240 volt circuit while handling the 120 volt wiring. The switches themselves only interrupt one leg of the circuit. The other leg remains energized, creating a potential shock hazard. It is crucial to understand that turning off a switch does not energize the entire circuit within the switch box. It only breaks the connection to the load, such as a light fixture. The wires entering the box and the switch itself remain energized unless the circuit breaker controlling that circuit is turned off. Before starting any work on a switch box, the first and most important step is to energize the circuit at the breaker panel. Identify the correct breaker that supplies power to the switch box and turn it off. It is essential to verify that the power is indeed off using a reliable voltage tester. A non-contact voltage tester can be used to check for the presence of voltage without making direct contact with the wires. However, it is always recommended to also use a multimeter to confirm that the circuit is de-energized. A multimeter provides a more accurate voltage reading and can detect any residual voltage or induced voltage that may be present. When using a multimeter, set it to the appropriate voltage range, typically 250 volts or higher, and carefully test the voltage between each hot wire and the neutral wire, as well as between the hot wires themselves. If the multimeter reads 0 volts, it is generally safe to proceed with the work. However, it is always wise to exercise caution and treat all wires as if they are energized until proven otherwise. Wearing appropriate personal protective equipment, or PPE, is crucial when working with electrical systems. Insulated gloves that are rated for the voltage levels you are working with are essential. These gloves are designed to protect you from electric shock by providing a high level of insulation. Safety glasses or a face shield should also be worn to protect your eyes from arc flashes or flying debris. Arc flashes are sudden releases of electrical energy that can cause severe burns and blindness. They can occur when a circuit is inadvertently shorted or when a wire is accidentally cut. Wearing safety glasses can help to minimize the risk of eye injuries in the event of an arc flash. In addition to gloves and eye protection, it is also a good idea to wear non-conductive shoes or boots. These types of footwear can help to insulate you from the ground and reduce the risk of electric shock. Avoid wearing any metallic jewelry or clothing, as these can provide a path for electricity to flow through your body. Installing warning labels on the inside of switch boxes is a proactive measure that can help to prevent accidents and injuries. These labels should clearly indicate the presence of 240 volts and warn anyone working in the box to take appropriate precautions. The label should be durable and easy to read, and they should be placed in a conspicuous location where they are likely to be seen. The warning label should use clear and concise language, such as "Danger 240 volts present. Turn off circuit breaker before working on this box." You can purchase pre-printed warning labels from electrical supply stores, or you can create your own using a label maker. When installing the labels, make sure to clean the surface of the switch box thoroughly to ensure that the labels adhere properly. It is also important to ensure that the labels are securely attached and will not peel off over time. If you are not comfortable working on electrical systems, it is best to hire a qualified electrician. Electricians are trained to work safely with electricity and have the knowledge and experience to identify and mitigate potential hazards. They are also familiar with local electrical codes and regulations and can ensure that your electrical system is installed and maintained properly. Attempting to perform electrical work without the proper training and experience can be dangerous and can lead to serious injuries or even death. It can also result in damage to your electrical system and create a fire hazard. When hiring an electrician, make sure to check their credentials and ensure that they are licensed and insured. You can also ask for references from previous customers to get an idea of their quality of work. A qualified electrician will be able to assess your electrical needs, provide you with a detailed estimate, and perform the work safely and efficiently. In addition to the specific precautions mentioned above, there are some general best practices for working with electrical systems that should always be followed. Firstly, always assume that all wires are energized until proven otherwise. Secondly, never work on electrical systems while standing in water or on a damp surface. Thirdly, use insulated tools that are designed for working with electricity. Fourthly, never overload electrical circuits or extension cords. Fifthly, regularly inspect your electrical system for any signs of damage or wear. Sixthly, replace any damaged or worn electrical components promptly. Seventhly, install ground fault circuit interrupters or GFCIs in areas where there is a risk of water exposure, such as bathrooms and kitchens. Eighthly, use arc fault circuit interrupters are sized to protect against arc faults, which can cause fires. Ninthly, familiarize yourself with your home's electrical system, including the location of the main breaker panel and the function of each circuit breaker. Tenthly, keep a flashlight handy in case of a power outage. 11thly, teach children about electrical safety and keep electrical cords and outlets out of their reach. 12thly, if you are ever unsure about how to perform a task safely, consult with a qualified electrician. Electrical codes and regulations are in place to ensure the safety of electrical installations and to prevent fires and other hazards. These codes specify the requirements for wiring, grounding, overcurrent protection, and other aspects of electrical systems. The National Electrical Code, or NEC, is the most widely adopted electrical code in the United States. It is updated every 3 years to reflect the latest technological advancements and safety standards. Local jurisdictions may also have their own electrical codes that are based on the NEC but may include additional requirements or modifications. It is important to be familiar with the electrical codes that are in effect in your area and to ensure that all electrical work is performed in accordance with these codes. Electrical inspections are typically required for new electrical installations and for major renovations or alterations to existing electrical systems. These inspections are conducted by qualified electrical inspectors who verify that the work has been performed in accordance with the electrical codes. Passing an electrical inspection is essential for ensuring the safety of your electrical system and for obtaining a certificate of occupancy for your home or building. Understanding basic electrical principles can help you to work safely with electricity and to troubleshoot common electrical problems. Voltage is the electrical potential difference between 2 points in a circuit. It is measured in volts and is often compared to the pressure of water flowing through a pipe. Current is the flow of electrical charge through a circuit. It is measured in amps and is often compared to the rate of water flowing through a pipe. Resistance is the opposition to the flow of current in a circuit. It is measured in ohms and is often compared to the diameter of a pipe, with a smaller diameter pipe offering more resistance to the flow of water. Ohm's law is a fundamental principle of electrical circuits that states that the voltage across a resistor is equal to the current flowing through the resistor multiplied by the resistance of the resistor. This can be expressed as volts equals amps times ohms. Power is the rate at which electrical energy is transferred in a circuit. It is measured in watts and is equal to the voltage multiplied by the current. Understanding these basic electrical principles can help you to understand how electrical circuits work and to troubleshoot common electrical problems. Proper grounding is essential for electrical safety. Grounding provides a low resistance path for fault current to flow back to the source, which helps to trip the circuit breaker and prevent electrical shock. The grounding system typically consists of a grounding electrode, such as a ground rod or a metal water pipe, that is connected to the electrical panel. The neutral wire is also connected to the grounding system at the service entrance. All metal enclosures, such as electrical boxes and appliance housings, should be properly grounded to prevent them from becoming energized in the event of a fault. Ground fault circuit interrupters, or GFCIs, are designed to protect against electrical shock by detecting ground faults. A ground fault occurs when current leaks from a hot wire to ground. GFCIs are designed to trip the circuit breaker when a ground fault is detected, which can prevent electrical shock. GFCIs are typically required in areas where there is a risk of water exposure, such as bathrooms, kitchens, and outdoor outlets. Arc fault circuit interrupters, or RFCIs, are designed to protect against arc faults, which can cause fires. An arc fault is an unintentional electrical discharge between two or more conductors. RFCIs are designed to trip the circuit breaker when an arc fault is detected, which can prevent fires. RFCIs are typically required in bedrooms and other areas where people sleep. Surge protection is designed to protect electrical equipment from voltage surges, which can damage or destroy electronic devices. Voltage surges can be caused by lightning strikes, power outages, or other electrical disturbances. Surge protectors work by diverting excess voltage away from the protected equipment. Surge protectors are available in a variety of forms, including power strips, plug-in devices, and whole-house surge protectors. Regularly inspect your electrical system for any signs of damage or wear. Look for frayed wires, cracked outlets, and loose connections. Replace any damaged or worn electrical components promptly. Ignoring these problems can lead to electrical hazards and potential fires. When working with electricity, it is important to stay focused and avoid distractions. Electrical work requires concentration and attention to detail. Taking shortcuts or rushing through a task can lead to mistakes that can have serious consequences. If you are feeling tired or distracted, it is best to postpone the work until you are feeling more alert. Always double-check your work to ensure that everything is properly connected and secured. Before restoring power to a circuit, carefully inspect all of your connections to ensure that they are tight and secure. Make sure that all wires are properly insulated and that there are no exposed conductors. Use a torque screwdriver to tighten screws to the manufacturer's specified torque. Over-tightening screws can damage the components, while under-tightening screws can lead to loose connections. After restoring power, test the circuit to ensure that it is working properly. Use a voltmeter to check the voltage at various points in the circuit. Use an ammeter to measure the current flowing through the circuit. If you detect any problems, such as low voltage, high current, or flickering lights, turn off the power and troubleshoot the circuit until the problem is resolved. Keep your work area clean and organized. A cluttered work area can be a safety hazard. Keep all tools and materials organized and within easy reach. Clean up any spills or debris immediately. Use a ladder safely when working at heights. Make sure that the ladder is stable and that it is placed on a level surface. Never stand on the top rung of a ladder. Use a spotter to hold the ladder if necessary. When working in confined spaces, such as attics or crawl spaces, be aware of potential hazards such as exposed wiring, sharp objects, and pests. Wear appropriate protective gear, such as a hard hat, gloves, and a dust mask. Use a flashlight to illuminate the work area. Follow all safety precautions when working with electricity, and never take shortcuts. Electrical safety is not something to be taken lightly. By following these tips and precautions, you can help to protect yourself and others from electrical hazards. Remember, if you are ever unsure about how to perform a task safely, consult with a qualified electrician.